All right, so let me get a full screen so I can see what I'm doing. So this is lesson set 24, and now new lesson sets come our way after this one. All right, where we're gonna, I think I mentioned in the last video, unit circle work, rational functions, cubics and graphing form, all the stuff that we still want to put in front of you is going to be put in front of you in the first few days after the midterm break. But right now, the last of the introductory lesson sets until we change up a little bit. So if you've done the other videos, if you've looked at them, you know what the questions are asking. So what's the equation of the line? X plus 10 plus 6, change in x, looks like 11, 6 to 2, down 4, move on. Slope-intercept form, minus 2/5 x plus 8/5 minus 35/5 is equal to minus 2/5 x minus 27/5. Move on. Let's get Rene Descartes in play. Thank you, Rene. I don't know where we'd be without you, Rene. All right, coordinates. I like to work with one side. I'll work with the x's and they're changing by 5. I'll work with the y's and they're going down 2. Okay, x and y intercept. Throw a 0 in for x. You got the y-intercept of 1, 1, 2, 8, 7 over 3. Throw a 0 in for the y, and you got the 0 in for y, the x-intercept. I hope I said that right the last time. 8, 7 over 4. Plot those 2 points. You got yourself a graph. Quick and easy. That's why it's a graphing form called standard form. All right, let's get this desk out of the way. Solving this equation, where do these 2 lines intersect? Let's find out that x value. So I'm going to multiply by 10, and I'm going to get minus 14x minus 40 equals minus 15x plus 100. Okay, so I'm going to bring the 15 this way, which gets me x. I'm going to bring the 40 that way, it gets me 140. Next problem. I'm going to multiply this by 2, so the y's cancel. I don't even have to write the y's, but I will. So we have 5x minus 2y equals negative 7. Multiplying by 2 gets me 4x plus 2y. Multiplying by 2, I have to say that to myself or I'll probably write positive 2 there. All right, so that did cancel. We get 9x equals negative 9. Nice numbers, so you don't have to work too hard. So x equals negative 1. We put negative 1 in there and we get minus 5. I need minus 2 to get minus 7. So therefore y equals 1. All right, take more time and solve that if you need to. All right, trying to get much better with our fraction work. I think we are finally there. So 9 times minus 3/4 is minus 27 over 4 plus 20 over 4. And so that is evaluated to be minus 7 over 4. When does f of x equals minus 4/5? One of our major concepts in algebra. Substitute a new name for f of x, which is 9x plus 5. Multiply everything by 5. 45x plus 25 equals negative 4. Last time I made a sign error. So 45x equals minus 29. I'm trying to be a little more careful. So therefore, x is minus 29 over 45. All right, 9x squared minus y squared. Every problem we want to write this as a product. Write this as a product. We have a difference of 2 squares, 3x plus y times 3x minus y. Difference of 2 squares. What's the range of this? The midline is 50. I'll circle it. This thing is 8 times plus 1 minus 1. That's all the sine function does. 5 regulates how fast you're going around the circle. Plus 50. That means I'm going up 8 to 58, down 8 to 42. What's my range? These are y values. They have to be what? They have to be less than or equal to 58, greater than or equal to 42. There's the range. That's all I asked was the range, so there's your answer. We'll be graphing those considerably during the second half of the term. All right, so I got 15x to the 4th. I got minus 35x to the 3. I like columns. I've got minus 20x to the 4th, So I'll put that in the x to the fourth column so I can count it up. I got plus 4x squared. Plus 4x squared is not going in the cubic column. So what do I have for an answer? Minus 5x to the fourth minus 35x to the third plus 4x squared. Closing any gaps from algebra 1. So I'm completing the square, so that's x minus 7 squared minus 49 plus y plus 2 squared minus 4 equals minus 28. So my center is, well, let's clean it up. X minus 7 squared plus y plus 2 squared, a nice Pythagorean triangle here. These are the areas. Okay, so what I'm basically doing is finding these areas to the side lengths, and this is a constant. What is that constant? 53 minus 53, adding 53, 50 and 20, so that's 81. Oh, how nice. So what's the center? Let's making sure you can see everything. So the center is 7 comma negative 2. That is not on the circle. What's the radius? 9. 81. All right, we talked about that enough that I don't think I have to say more than that. All right, so with a singleton variable, it seems like you could say, okay, we got answers over here to equations. Let's use capital A. Of course, this is based on the letter x, but how would you get x alone here? Because that would mean you have an input to an output. And that answer is really what this stands for. G minus 1 of A. All right, well, let's work backwards here. What's the first thing you're going to do? You're going to say, well, I'm using the letter A. Oh, okay, I'll do it over here. A minus 3 takes care of that, divided by 5. A minus 3 over 5. Going to do a lecture on this tomorrow, actually. The inverse of E ln of A minus 3 over 5. And what's the last thing we're going to do is add 2. So we're going to add 2. So what was my function based on the letter x? 2 plus the ln of x minus 3 over 5. Right? This is a new concept for you. You've been working with it now for 20 lesson sets. Okay? So it's not new in that regard, but when the semester started, didn't know anything about this function. I hope you know a whole lot more now. So what would be a nice number to work with up here? I think I would work with, how about we work with 2.7. 2.7 minus 2 is 0.7. E to the 0.7 is approximately 2. Times 5 is 10. Plus 3 is 13. So I started with 2.7. And my answer was 13. So now I'm going to plug 13 in. Minus 3 is 10 divided by 5 is 2. What's the ln of 2? 0.7 approximately. And 2 plus 0.7 brings me back to what I started with. So that's the inverse. All right, I got to do a little, move this table out of the way, be right back. Go, oops, crash, bing, bang, boom. All right, so the same thing here. Can we just do it like saying, okay, I got an answer to an equation. What's the first thing I'm going to do? Multiply by 3. I'm going to add 2. And then I think I'm going to take the cube root. How do I check to see if it's right? Easy number. I'm going to pick a 2 here. That's 8 minus 2. 6 divided by 3. Oh, a 2 gets me a 2. A 2 better get me a 2 here. 6 plus 2 is 8. The cube root of 8 is 2. I'm moving on. Vertex minus b over 2a. Hoping all of this is going to be remembered at your next level of study. Minus b, 20 divided by 10. So I now know that the x value is 2. Cup shape up. I've got my 2. I'll check to see if I made a mistake. 2 squared 40. I did make a mistake because what I'm getting here is 40 minus 40. I got to do this again, unfortunately. All right, so minus 20 is 20. I forgot to double the 10, 20, so it should have been 1. And that's how you can tell you got a mistake. If I put a 1 in, I get 10 minus 20. That's what I'm looking for, the 2-to-1 opposite relationship. Fortunately, I took the time to do that, so I got minus 10, minus 17. So what did I plug in? I think I plugged in a 1. Yep. So 1 comma negative 17 is the vertex of that quadratic. Name that tune. All right, so I know that I want negative 4 to act like a 0 because 0 squared is a minimum. But in this case, I'm raising that minimum up 3 units. Minus 4 to 6 is a change of 100. We talked about y. This minus 4 to 6 is a change of 10. But don't forget, there's a little more to this calculation that's changing. And if that change of 100 units plus 3 doesn't take you to 22, then you better get rid of that 100. If you get from 3 to 22, you better go up 19. All right, I'm going to take out an x. I know I could have taken 2x out, but I'm just in the habit of doing 6x plus 2 equals 0. And I think it's good that you see negative 3 as one of your x values. And I hope at some point you start writing 0 each and every time. Most of you are now. Saw some real progress in the last couple of tests. And closing a gap from Algebra 1. 5x squared 50, so that's minus 50 divided by 5 is minus 10. Doing the plus minus square root, plus minus square root of a negative means you're putting I on the outside of the radical. And I guess that's it. We're done. Okay, there's no more to that one. 5i to the 23. I hope at the end of the term you look at that and you say, oh, negative 5i. Where is it coming from? It's coming from 5i squared 11 times I. All right, so that means I'm doing 5 times negative 1 times negative 1 times negative 1 times negative 1 times negative 1, 11 times, which is odd. An odd number of negatives gets us a negative. So there's negative 5i. Okay, square the first term, square the last term. That's automatic. What happens in the middle? Double that product. What's 9i squared become? That's a 9, folks. Minus 9, so 40 minus 42i. Doing the same thing here, but think of this as 3n minus 8. What if I squared that? I'd get 9n squared minus 48n plus 64. That didn't change. The exponent didn't change here at all. So what are we going to get with this problem? We're going to square the 3. Don't forget to do that. A to the 12th, B to the 24. And now I have A to the 6th, B to the 12th times C. That's still going to be there. A to the 6th, B to the 12th, C. How many do I have? 3 times minus 8, minus 24 doubled, minus 48. Squaring a term is always going to be positive, so that's 64c squared. Okay, that's a run-on, so I'm going to get rid of it. You can always have this thing on called a cursor, and I know that you can move it so that these videos you can go forward and backwards. I learned that the other day. Yeah, I'm not generationally challenged at all. All right, so what I'm seeing is 2 times the square root of 36 times the square root of 2 minus 2 times the square root of 9 times the square root of 2. I think that is 12 root 2 minus 6 root 2. I think those are root 2's, and I think I'm counting them. 6 root 2. All right, we talked about this problem, cross products. We've explained that in class. So 12x squared equals 25x. What are we going to do? We're going to subtract and set it to 0. I like to take x out. If I take x out, boom, and I remember that one of my answers is 0, I'm only solving this, which is 25 over 12. So my second x is 25 over 12. All right. Oh, I'm here. Roots. Okay, most of you are getting this right now. This is great. X is 8, plus or minus. I've got to do what to get to 0? Well, that doesn't intersect that, so I know I got an imaginary answer. I've got to change by 3 units. And I've got a square and I've got a multiplier, so I got to do those inverse operations. The inverse of operation of squaring is plus minus square rooting. The inverse of multiplication is division. And the inverse of addition is subtraction. I said something there awkwardly. That's okay. So if you put this in graphing form, 2 parentheses x minus 8, for anybody who hasn't figured this out yet, that's what you're solving. And if you do the inverse operation, you should get here. Factor 27 minus 8. Well, that's a special case. Are these numbers? And a factor means write that as a product. So how could I write 27 minus 8 as a product? As follows. 3 minus 2 times 9 plus 6 plus 4. Check it out. It works. So how do I get this? I'm looking at the cube root of 27, obviously, minus the cube root of 8. I'm keeping that symbol minus. I need cancellation. 3 times 2 is 6. It's like a conjugate. If I multiply this out, I'll do it one more time. 3 times 9, 27. 3 times 6, 18. 3 times 4, 12. Minus 2 times 9, minus 18. Minus 2 times 6, minus 12. Minus 2 times 4, minus 8. Let me get rid of a few terms. Looks like 27 minus 8 to me. So that one's done. All right, now we're looking at solving that. I can see 3 goes into everything. So I'm going to divide by 3 minus 5x. I'm going to divide this by 3 and bring it to the other side. Minus 4 on that side is positive 4 here. And I look at this and I go, oh, positive, negative. Then I got an x minus and an x minus. When I do the minus times the minus, I'll get positive 4. What are the factors of 4 that get me 5? 1 and 4. And if that equals 0, I think I have 2 answers here. 1 and 4. Let's check it out. Put 1 in. 3 minus 15. Oh, that's negative 12. Let's put 4 in there. 48 minus 40. What did I say? 4? Oh, 48 minus 60. 48 minus 60. I wish I could figure out what that is. Oh, yes, minus 12. Seems like it worked. Come on, Renee, we're almost done. Then I just got to do numbers 31 through 57, and then another video on solving equations because it's midterm, and we should be able to see some patterns. All right, let's get this here. 2m squared minus 3m minus 20. Well, I'm going to write what I know has to be true. Hope this marker lasts a little longer. 2m times m. Oh, I got that one. Now, I know whatever I pick is going to be doubled, and I want to get near 3. How about I try 5? 5 times 10 and 4. No, that didn't work. How about I try 4? 8 and 5. 8. Oh, 8 and 5 gets me minus 3. Oh, that was a good guess. I want negative, then I want the bigger product to be negative, and that's minus 8m. Plus 5m, this looks like it works. All right, so what do we have here? A problem that continues to be a problem. Of all the problems on your test, this one's bothering me the most because we continue to make a mistake. Let's try not to. Let's do all of bingo, bango, bongo. Okay, I'm going to bango, bongo, whatever I'm at. I'm going to leave this x minus 2, x plus 1 in case what's up here cancels. You may do the same. You do not have to multiply that out. If you do multiply it out and you make a mistake, there'll be a deduction. 7 times x plus 1. 7x plus 7. I got to be careful now. It's towards the end of the video, which is where I usually make mistakes. But I think I'm going fast enough that I'm avoiding some of my carelessness. X minus 2 times 3. 3x minus 6. Okay, now I'm going to get rid of the parentheses. I really don't need this one. What does it mean to subtract something with 2 parts? It means to subtract both parts. What was positive 3x is now minus 3x. What was negative 6 is now positive 6. I think I'm ready to doctor this up. 7x minus 3x. I'm hoping people say 4x. 7 plus 6, 13. Now, this one bothers me so much. I could have made a careless error. It's towards the end of the video. What would be a nice number to plug in? Up to plug in 2. 2 minus 2 is undefined. Oh, plugging in 2, it's still undefined. That didn't help me much. How about we do 5, 6? Well, now let's take care of this one. Let's make this one 9. Yeah, no really friendly numbers here. So is it worth taking the time? 70 problems in 70 minutes? You got to trust your work on this one, I think. All right. Really not that hard to find some numbers, but end of the video here. And I get careless at the end. And if I get hung up, I'm going to be embarrassed. So I'm going to let that one stay. 29. Okay, this is a distance formula here, but we don't do the distance formula. We try to envision the following. 4, 6. What's D? D is equal to 16, and 36 is 52, square root of 52. Okay, so what did we do? We did that, 16, we did that, 36. That has to equal what? That constant unless I made a mistake, I didn't. That's 4 times 13, so if you said 2 root 13, I'll take either. This tells me you understand the concept. X minus 5, I gotta have an x to get x squared. To get minus 4, I better put a 1 there. There's my 1x, I'm now at -5. I gotta get to 19, so I think I gotta go up 24 over x minus 5. Let's see if I put a careless error in here. X equals 5 is the friendly number. Let's see if I get 24 when I plug it over here. 25 minus 16 plus 19. Minus 16 plus 19 is 3. 25 plus 3 is not 24. I think I made a careless error. So minus 5 to get to 19 is plus 24. I like that. So plugging in 5. Oh, that was plugging in 5. There's my error. There's my 20. 5 plus 19, 24. Okay, I almost got through the video without making a careless error, but I at least caught those places where I made some gaffes. All right, so I'll upload this. I got Yasser to back me. All right, and you found a couple of spots in two or three videos there. So I'm just copying what you write, putting it into the introduction to let folks know that there was a mistake there made. And that's very helpful because even though I'm only teaching one class, I'm pretty busy these days doing this, which I'm hoping will help people march their way up to a foundation to tackle calculus. All right, the next 24 we'll tackle more trig, and then we can jump into the calc. And so hopefully by 75 videos, yeah, you might be tackling an introductory calculus level at the college level. We'll find out. That's my goal. All right, everybody have a nice, warm, and safe day.